Hello students, welcome back. Now let's go to section 2, and section 2 is about hypothesis testing for binomial proportions. The theoretical background is of course the normal approximation theorem. For binomial sum, for binomial average, we have these. But of course, here in hypothesis testing, we're not going to use binomial sum. Everything is based upon binomial average. So we're going to stick to the second formula down here, which can be summarized like this. So mu is the proportion, and standard error formula is like this, square root of p, 1 minus p over n. But remember, we are doing hypothesis testing, so all these are based upon null. Remember, we do the normal around the null. All right, here's an example problem. The following is a blood type distribution table of the US based upon a recent study published in 2008. And if you're interested in the source, they're here. All right, suppose that a random sample of 150 recent donations at a certain blood bank revealed 78 were type A blood. So we have 78 over 150, so 52% of blood that's in the sample are A type. Now let's go to this for entire US population. We have 35.7% of Rh positive A type and 6.3% of Rh negative A type. So from this, we have 0.357 plus 0.063, 42%. This is for national average. And this is observed proportion in this sample study. Okay, all right. We have all those numbers. Now let's set up the hypothesis. So what's the null hypothesis? Mu is approximately equal to what? 0.52 or 0.42? It should be 0.42. This null hypothesis, which it did not come from the sample. And down here, we use the same number, mu 0, and the problem said higher than, so h is mu greater than 0.42. Another is, of course, the sample study. We got proportion of 0.5 to 52%, which is greater than 42%. So that's another reason why you can do mu greater than 0.42 for alternative hypothesis. Another thing is this one. I usually want you to complete this SE computation at step 1 at the setup stage. Do not postpone, because if you postpone, you may get a little bit confused. Why? Because there are two competing proportions, 0.52, which is observed proportion, and 0.42, which is null proportion. And you have to use null. You see, do you remember drawing the normal picture? We used to do something like this, draw a normal picture, and then null goes here to the center. So everything has to be based upon null hypothesis. Now, let's go back to this problem here. What's the null? It's around 0.42, so that's what you have to use. Not 0.52 here. 0.52 will be used for interval estimation. 0.42 will be used for hypothesis testing. All right, now that we have all these, let's go to initial picture. Normal picture around the null, and then greater, so you want shading to the right. And Alpha is 1%, so here we go, and we want to find out the critical value. How do you find this critical value? It's easy. Z value is end minus center over SE. And that should be approximately equal to the z-score associated to this 1%. If you look up the z-table, you're going to get about 2.33. I've seen it so many times, I ended up memorizing that. Let's see. So 1% to the right, so I must find 99%. Right here, 0.9901. So 0.9901, that's the closest. That's 2.33. Let's go back to the problem. All right, now, what is the end in this problem? X, the critical value, and the center is 0.42, the null. By the way, some bigger font will be helpful. And SE is square root of proportion, 0.42, the null proportion, 1 minus that, divided by sample size of 150. From here, you can solve for X, and then using that, you can determine where the 0.524, blue region or the red region. Blue, close enough to null, so null wins. Red, too far away from the null, so null loses. Okay, let's go ahead with the computation. Same computation as before. As a matter of fact, here I'm using a little bit more accurate figure using Mathematica, 2.326, not just 2.33. In any way, we get this. And then 0.514 is a critical value, and 0.53 is actually a little bit bigger than that. So 0.52 here. So what can you say? The proportion of A-type in this blood bank or in this neighborhood is higher than that of the national average of 0.42. It is well known that ethnic Asian people have, not just entire Asia, Asia is too big, the Far Eastern Asian, Korean, Japanese, Chinese, those Taiwanese, those population generally have higher percentage of A-type. And it is well known that African descents have higher proportion of Rh negative, for instance. So there's a bit of a difference, and that is a conclusion. Alternative wins. You can say that there's a sufficient evidence that the A blood type is more prevalent in this neighborhood compared with the national average. Now, what if we use the probability value approach? Same setup, but here null is 0.42 and we just go directly with 0.52. And then we want to find out this probability and compare this red probability with alpha. Greater than alpha, then null wins. Less than alpha, then null loses. Remember, this p-value, this probability value, p-value is, roughly speaking, this p-value is associated to the probability that null is right. So if that's big, then we select null. If that's too small, then we're going to go away from null. So let's do the computation. End minus center over SE. 0.52 minus 0.42 over SE computation, which is, as a matter of fact, this. If we do all that, we are going to get about 2.481. If you look up the Z table, go up to 2.48, and you're going to get appropriate probability. As a matter of fact, here I used mathematical computations, so I have 6 decimal digits. But if you look up the Z table, you're going to get only 4 decimal digits. In any case, it's less than 1%, you can see that. And therefore, probability value is less than alpha. Less than alpha, alternative wins. Null loses. By the way, here I used the same mu, but some people are really keen on selection of characters. Mu is for mean, and this is proportion, so we have to use Greek letter associated proportion, which is pi. And then this is absolute proportion, not x. It should be p bar. And then this is proportion pi greater than 0.42 equal to 0.42 and so on. This should be proportion, and this should be, pi 0, not mu 0, like those. Yes, you can do it like this, but I usually don't bother because in the end you have to plug in numbers anyway. The choice of characters are not that important. Another reason is I don't like to use pi because pi is usually used for something else. In statistics, people use pi all the time for proportion, for population proportion, but I'm a mathematician, closer to mathematician than statistician, so I do not want to use pi for, proportions. In mathematics, pi is 3.14. That's transcendental irrational number. But our textbook is written this way with pi. Me, personally, I don't mind. I have encountered a faculty member was taking some points off using mu and x's there. I don't agree, but if you encounter a faculty member like that, you just adjust to that person. Okay, so much for section 2, hypothesis testing for binomial proportions here. We're going to talk about section 3 in a separate video.